What's up, guys? It's me, Sir Ernest, and today we're going to continue our demonstration on our virtual experiment on friction. Previously, we've discussed part 1 of our experiment, wherein we calculated the coefficient of static and kinetic friction by analyzing this graph. Okay, in our next video, or in our next demonstration, we're going to do part 2, wherein we're going to calculate or estimate the coefficient of static friction as determined in inclined plane. And we're going to use forces on an inclined plane as our demonstration. So in this environment, you'll be able to study the forces on the block that is on an inclined plane, and then you're going to look into, from that, we're going to calculate the coefficient of static friction. And let's begin. Okay, so here we have several things here. First is this is our block. So this will determine the surface that you're going to use. Okay, so for the first surface, you're going to use any yellow block, like this one, on a brown surface. Okay, and then the second part, you will use any gray block on a yellow surface. So how they're going to change these surfaces? The way that you're going to do that is by changing the coefficient of frictions. So for example, if you're going to click upward, you will see that this will change. So this is still brown. This is already this is still considered as your first surface. Either this one, or this one, or this one, or this one. Okay. But as you increase, you will notice that later we're going to change the surfaces. So for example, this is an example of a gray on a yellow surface, which is considered to be your second surface, like this one or this one. Okay, so let's try the first surface. So let's choose maybe, let's say this one. Okay, so let's say this is your surface, yellow on the brown surface. And then the first thing that you need to do is to enter here the set coefficient of static friction. So in this case, that's 0.26. Okay, so this is 0.26 coefficient of static friction. Okay, so let's zoom it here. Okay, so that's 0.26. Now we'll also record the mass of the block. So that's 537 grams. So in kilograms, that's 0.537 kilograms. Now what happens here is that if you're going to change the angle, so let's click this angle, you will notice that the incline, the angle of inclination of this inclined plane starts to increase. And then when you click it again, it will stop. So what you're going to do in this part of the experiment is that you will find the angle of inclination where this block would start to move. Okay, so let's try this. Okay, so you can do it incrementally until you're going to notice that this block will start to move. Okay, so let's do this. Okay, so you're already at 13 degrees, 14 degrees, 14.7. Okay, so let's do this again. Again, same block, same coefficient of static friction, and then you increase the angle. Click to freeze, click to change. Okay. Okay, so let's do this again. Okay, so once you see that the block starts to move, you hit freeze, and then you record this angle. So this is 15.4 degrees. And then you're going to take the uh, tangent theta. And you will see later that this tangent theta is actually the coefficient of static frictions. Okay, so let's try tangent 15.6. So the answer here is 0.0228. So this is the actually the estimate of the angle of the coefficient of static friction. Now your special task is to show that tangent theta is actually equal to the coefficient of static friction for this kind of system. Okay, so for an inclined plane like this. Okay, in the supplementary videos, I will give you some hints on how this can be shown. Okay, okay. Now let's reset the system and let's try to increase the block's mass. So let's say 648 grams. So this is 0.648 grams. Now let's compute for the angle of, let's determine the angle of repose. So we call that the angle of repose. The angle at which this block will start to slide. Okay, so this is 15.6. And let's reset the system and then decrease the block's mass again. 5.2, and then let's do the increase again. This is 14.6. So you notice that if you change this value again, okay, so you can try again 648 by slowly changing the angle like this. Okay, so this is should be 14.8. Okay, this is the system, and then let's try the first one again. So it really takes some practice to do this. So you have to be very careful. So this is 14.7. System, and then let's increase this again to more than. So this is 0.829. Angle again. Okay, so this is 14.7 again. Set the system. Let's say more than a kilogram. Let's say almost a kilogram. So that's 0.940. And let's do this again for the last time. Okay, so this is, let's say 15.2 degrees. And then you calculate all the tangent thetas, and then you compute for the percent error by comparing the coefficient of static friction as our accepted value, and then tangent theta as our experimental value. So for example, for the first trial, so we take the absolute value of the difference between 0.26 and 0.28, and then divided it by 0.26. That's our accepted value. And then let's multiply it to 100%. And the answer is 7.69%. Again, so that's 0.28 minus 0.26 divided by 0.26 times 100 equals 7.69%. Okay, and then lastly, we're going to calculate print screen our last trial. Okay, so again, let's print screen this one, this whole part, copy, then you're going to paste his here, and then you're going to adjust. Okay, so that's it. That is our experiment today. So the second part of our experiment. So again, you're going to change the blocks or the surfaces involved for the second surface. Okay, and then you're going to answer questions here and your problem solving. Okay, so that ends the demonstration for today's experiment. I hope you understood the experiment and you learned something today. Thank you guys for watching, and I'll see you guys next time. Bye bye.